Hello everyone. Today's topic is measurement of study variables. Today we will discuss about definition of variable, the classification of variables and their respective scales, measurements of measures of central tendency and measures of dispersion. So variable is any characteristic, number or quantity that can be measured or counted. So based on the source of data, we can have nominal variable, ordinal variable, interval variable, or ratio variables. These all four can be remembered as NOIR. N stands for nominal, O stands for ordinal, I stands for interval, and R stands for ratio variables. Now, most of the times, these variables and data, they are used synonymously, but they are not exactly the same. So data, they can be qualitative or quantitative based on the type of the variable. So qualitative data is also known as categorical data. It is of two types, nominal data and ordinal data. So the nominal and the quantitative data, which is can be of interval and ratio data. So first of all, the nominal. So here the nominal data is constituted by nominal variables which have well-defined categories. They can be labeled and they have a definite magnitude, but there is no order between the values. For example, we have eye color and race. So one special type of nominal data is dichotomous data where they can have only two categories, for example, male and female, the answers as yes or no. Then we have ordinal data, which consists of ordinal variables. Here, apart from the categories, they have particular ranks and orders with well-defined magnitude. Here, example is the severity of pain, like mild, moderate, severe, and class scores of students like first, second, and third, stages of cancer like first stage, second stage, and third stage. Then we have interval data. It is again divided into two types, discrete data formed by discrete variable. Here, the values can be counted as integer or full values like 1, 2, 3. So, like the example is number of siblings or family size. Then interval data, one other type is here continuous data, which is formed by the continuous variables. Here, the quantities have magnitude and they have specific meaningful values and they can be measured, but there is no true 0 point. For example, temperature in Celsius degrees. Here, the temperature it has meaningful value, but no true absolute 0 point means zero temperature means it does not mean that there is absence of temperature. The ratio scale, the ratio data, it is constituted by ratio variables, and again the quantities they have a meaningful value, they can be measured, and they have absolute true 0 point. For example, height, weight, blood pressure, and pulse rate. So here, absolute 0 point means, for example, if we take the pulse rate, the 50 difference between 50 and 100 is exactly 50. The pulse rate 0 means there is no pulse. So summarizing the measurement data, just measuring the data does not make any sense and we cannot draw any meaningful conclusions from them. So we need to summarize the data to draw the meaningful conclusions. So here from summarizing the data, we can see the distribution patterns, indices of central tendency, indices of dispersion. So distribution pattern can be symmetrical or skewed distribution, or they can have bimodal or multimodal distribution. So among the indices of central tendency, we have mean, median, and mode. And for dispersion, we have variance, mean deviation, standard deviation, coefficient of variation, etc. Now, so by summarizing the data, we can see the distribution of the data. It is helpful for the, so this first distribution is normal distribution or Gaussian distribution. Here it is the frequency distribution table. This is basically a bell-shaped distribution or Gaussian distribution, also known as normal distribution. The graph is here bell-shaped, and 95% of the variation or the observations, they lie within 2 standard deviations. And this is best for the continuous data. Then we can have non-normal distribution. It can be positively or negatively skewed distribution, or we can have bimodal or multimodal distributions. So these are the various type of distribution patterns. Now coming to the indices of central tendencies. So they tell about how close to the central value are observations. So observation generally tend to cluster around a central value, usually mean. So the indices are mean, median, and mode. So first is arithmetic mean or simply mean. It is most commonly used measure of central tendency, and it is the best for the continuous and discrete data. It represents average of given set of values, and it is actually sum total of all the individual values divided by total number of values or sample size. So here it is denoted by x bar. Here x is number of x1, x2, x3 is number of individual observation, and x bar is the sample mean, and n is number of observation, and for population mean mu is the symbol. Now the only disadvantage of this is that it is very sensitive to extreme values, and it cannot be used where the outliers are present. Now let's calculate mean from the given example. Here, the gain in weight of albino rats over a period of 5 days are 5, 6, 4, 8, and 7. So by calculating from the formula, putting the values here, the sum total of individual values, and here n, that is total number of values, is 5. Then putting the values here, the sum total comes out to be 30 divided by 5. The arithmetic mean is 60. Now next indicator or the measure of central tendency is median. It is robust measure of central tendency, and it is actually the midpoint of the observation. Here, when the observations, we can see that when the observations are aligned in the ascending order, 50% of the values lies below the median and 50% of the values lies above the median. So it is the middle value which divides the observed value into the equal parts. So advantage is that it is not affected by extreme values, and it is a better indicator or the measure of central tendency than mean. Then how to calculate the median? So first of all, arrange the data in ascending or descending order. So if the n is odd, then median is calculated by the middle value, and if n is even, then middle two values are taken and average of those values is calculated. So here, as we have already discussed, that these are the two data. Here the extreme value is present, but the median here is unchanged. Now let's calculate the median from the given example. These are the marks obtained by 20 students in class test out of 100. So find the median. Now firstly, we arrange the data into ascending order. So we have arranged the data in ascending order. Now let's find out the n. So here n is 20, and let's find out this median value. 69 and 70 are median values. Now let's take the average of middle values, these two values, and the answer comes out to be the median value is 139 divided by 2, comes out to be 69.5. Next comes the mode. It is most frequently occurring value, and it is used for nominal data. It is used when values are widely varying. For example, if we want to find out the maximum number of students who enrolled in a particular course, we need to find a mode. Now let's take another example. The hemoglobin level of individuals visiting a clinic is 6, 11, 10, 12, 8, 9, 11, 7, 12, and 11. So most frequently occurring value or mode here is 11. Now, whenever there is a normal distribution, so we take all these median, mean, and mode coincide. But in case of non-normal distribution, all these can have different values. Now, knowing just the measures of the central value or the central tendency is not sufficient. It does not give any idea about the variation in the sample or in the population. So we need to know the variation from the sample. So how do we know? So these are the indices of dispersion by calculating the range, interquartile range, then mean deviation, variance, and standard deviation. And lastly, uh, all these above are absolute measures of dispersion. Last is the coefficient of variance. This is the relative measure of variance, relative measure of dispersion. So indices of dispersion tells about how far away are individual observation from the central value, such as mean from the sample. Now first measure of dispersion is range. It tells about the spread of the data. It is the difference between highest and the lowest value of data. So it measures, it is the best for the interval and ratios data to measure a variation. So the calculation here, it is value is highest value minus the lowest value of data. So in this is the lowest value and this is the highest value and this is the range. Now let's calculate the range from the following data. So here the lowest value is 2 and the highest value is 35. So the range comes out to be 35 minus 2, that is 33. Now the advantage of range is it is quick and easy indicator of dispersion. It is best for symmetric data with no outliers. Outliers here means the extreme values. Now the disadvantage is that it only takes into account two data set points, that is extreme values, but it ignores the middle values. For the data which have extreme values, the interquartile range is rather preferred. The interquartile range, it is another measure of dispersion. Here, the quartile divides the data into 4 equal parts. Similarly, the deciles divide the data into 10 equal parts and percentile divides the data into 100 equal parts. Now, the interquartile range is given by the difference between first quartile and the third quartile. So here, in this, these are the 4 parts, that is first 25% for 25%, second 25%, third 25%, and fourth quarter. So this is the minimum value and this is the maximum value. So Q1 represent the midpoint of the first 25% of the data. Q3 represent median of second last quartile, that is last 25% of the data, and Q2 represent the median or the middle value of middle 50% of the data. So the interquartile range is Q3 minus Q1, whereas range is maximum minus minimum. So that is, this is the range, and this middle 50% gives out to the interquartile range. So the advantages of interquartile range, it is not affected by extreme values, and rather it is preferred when the extreme values are present. Disadvantage is that it ignores the maximum and the minimum, that is extremes of values. Second is, it takes into account only the middle 50% of the values. How to calculate the interquartile range? First, we arrange the data in ascending order. Then we find the median of data set Q2, and then we find Q1, that is median of lower half of the values. Then we find Q3, which is median of upper half of the values. So interquartile range is Q3 minus Q1. For example, let's calculate the interquartile range of following body weight of children who attended pediatric OPD. Firstly, what we do is we arrange the data in ascending order like this. So minimum is 7, maximum is 16. So now we find out the median or the this Q3 and Q1. So the median or the midpoint of the Q3 is 12, and Q1 is median of the first quarter. So 11 is the mid value. So interquartile range varies from 8.5 to 12. Then we come to the mean deviation. It is average of absolute deviations ignoring the sign of the observation from the arithmetic mean. So the advantage of mean deviation is that it takes into account all the observation in a given data set, but it ignores the sign of difference of value of observation from the arithmetic means. This is the disadvantage. That means if it does not tell that whether our value is having the positive deviation or the negative deviation. Then to overcome this, we have a variance. So another disadvantage of this mean deviation was when we add all the mean deviation, the result comes out to be 0. So it was not appropriate method measure of the dispersion. Then we have variance. It is useful again for the interval ratio data. It is average of squares of deviation from the mean. So we square the mean deviations and we take the average. So the formula is summation x minus x bar square divided by n. So here for the calculating the variance of a sample, we usually subtract 1 from n in the denominator. So the formula comes out to be n minus 1 is the denominator. So why do we subtract this 1 from the denominator? Because there are n minus 1 values which are independent from the mean or the central value. So it is, but the variance, it is very awkward unit of measurement as the values are squared. But it is, so therefore it is not very frequently used. So the most frequently used measure of variation is standard deviation. It is again used for interval ratio data. The formula is square root of average of square deviations of observation from the mean. So this is the definition of standard deviation. So it is the best measure of this dispersion. This tells how far away from the data set, from the mean, are our individual values. So standard deviation is also calculated by square root of the variance. So then the minimum value for standard deviation is 0, but never negative. So the advantage is the units are same as the individual variations in the observations in a data set. So the formula is square root of summation x minus x bar the square divided by n minus 1. So it is denoted by SD or small s. So caution must be exercised while using standard deviation as a comparative index of dispersion. Suppose we have calculated here the weight of newborns of elephants and weight of newborns in the mice. So here the total number of observations are same, but when we calculate the standard deviation, here the standard deviation is 56 and here the standard deviation in case of mice is 0.25. But it is incorrect to say that elephants show greater variation for birth weights than mice because of just the higher value of standard deviation. So to overcome this difficulty, the coefficient of variance is used. So it is a relative measure of variance or dispersion. So it is used to compare the relative variability in different groups. So by definition, it is the coefficient of variance is it expresses standard deviation relative to its mean in the form of percentage. So advantage here is that it is unitless number and it is used to compare the groups when they have different means within the group. Then the different units of measurements, when they are involved, we can use the coefficient of variance. The formula is standard deviation divided by arithmetic mean multiplied by 100. Now how to calculate? For example, a student measures fasting blood glucose level of 100 participants. Mean sugar level was measured as 110 milligram per deciliter. The standard deviation was 11 milligram per deciliter. Calculate the coefficient of variance. Here, arithmetic mean is given as 110 milligram per deciliter. Standard deviation is 11 milligram per deciliter. So putting the values in this formula, we get the coefficient of variance is 10%. Now let's summarize. This was all about the measures of dispersion. Now whatever we have learned, now we will summarize. Now there are various scales of measurement here depending upon the data and the variables that are the source of the data. Now the nominal scale or the nominal data have definite categories in this. They can be labeled, they have the magnitude, but there is no meaningful order and difference is not measurable. We cannot add or subtract the individual values. There is no absolute 0 point. We cannot multiply or divide. And in ordinal scale, the categories are labeled based on their magnitude, but there is a definite or meaningful order between the individual values, but the difference is not measurable. Here we cannot add, subtract, or multiply, and also there is no true 0 point. In interval data, here categories are labeled, they have defined magnitude, there is meaningful order, and the magnitude is difference is measurable, and we can add or subtract the values. But there is no true 0 point, and we cannot apply multiplication or division because the units might be different. Then we have ratio data, or here we can they have the categories are well labeled, the meaningful order is there, the difference is measurable, addition and subtraction can be done, there is true 0 point or absolute 0 point, and we can multiply or divide the different quantities. Then what are the descriptive statistics that we can apply here? In the nominal data, we can only see the frequency distribution, percentages, mode, but we cannot see percentile, median, range, mean, standard deviation, or geometric mean. In ordinal data, we can only see frequency distribution, percentage, mode, and percentile. For interval data, we can see the distribution curve. Then we have percentage, we can apply the mode, percentiles, then median, range, mean, and standard deviation. But we cannot apply geometric and harmonic mean. Whereas in ratio data, we can apply all these, including the geometric and harmonic means. And about the indices of central and tendency and dispersion. So mean and standard deviation, they are used when though there is no extreme values, they are the most sensitive methods of central tendency and dispersion respectively. When we use median and interquartile range where there are extreme values, then the mode and the range, they are rarely used, and they are used when they have widely varying values, that is the qualitative data. So that is all about today's lecture. Thank you.